Good evening, class. My name is Reynard Flanagan and my partner is Picasso Dutta, and we are going to be talking about our project, which is, for now, titled SPY Sector ETF Pattern Recognition. Our academic advisor for this project is Dr. Kashana. So here we just have a brief description of some of the main goals and questions that we are going to be answering with our project. So first, we are going to be working with neural networks to determine volatility pattern recognition for the 10 ETFs, the 10 sector ETFs rather, that are part of the SPY and then also on the SPY itself. To do this, we will be using k-mean clustering, and we are going to be clustering the graphs into popular technical patterns such as the head and shoulder pattern and the cup and handle pattern that we will be coding in Python. Based on this pattern clustering, we want to see which of the 10 different ETFs or which plural of the 10 different ETFs delegate the volatility and return movement of the SPY the most. So here we have the project progress. So we are currently in the process of collecting data for the 10 sector ETFs that you can see in the next bullet, as well as that for the SPY. We will be collecting both the 1-day return and volatility numbers as well as the 1-minute return and volatility numbers, so we can start the actual analysis early next week. Picasso will talk about some of the analysis that he performed already based on the articles that we read earlier. So additionally, we also performed some more background information and studied some previous works that were similar to topics that we are studying for our projects. And lastly, we started certain components for the final written report already. So now Picasso will talk about some of the analysis he performed based on the second article we talked about last week.
So now let us talk about Article 2, which was basically integrating technical indicators with neural network. So the daily prices will be processed with the technical indicators and by tuning the parameters of the indicators to achieve better results. Finally, the model will use MLP, multi-layer perceptron architecture, and finally the data will be trained using Apache framework. Now for this week, we have worked on dummy data, which is the daily price of XLE, it's energy ETF. However, we will replace it by the required 1 minute or 5 minutes data. So we've calculated the daily and the annualized volatility. We have also tried to establish a relationship between the daily volatility and the closing price. And finally, we have added one technical indicator to the closing price. So here the graph shows a comparison between the daily volatility and the closing, and it is found that there exists a significant negative correlation between the two, which is 0.55. Annualized volatility as per our calculation is 20.63, which is pretty close to one published on the internet, which is 19.81. Now the updates for our next week will be like replacing the daily price with either 1 minute or 5 minutes data based on the availability, and finally adding 2 or more indicators to make the data ready for training with the neural networks.